A committee of 4 is chosen from a group of 7 men and 6 women. How many different committees can be chosen in different scenarios? This is a little bit more like an exam question, particularly part C, which is a little bit more involved. But let's go from the beginning. For part A, there are no restrictions. So if there are no restrictions, that means we need to choose 4 people from these 13 people. So that is 13 choose 4, because it doesn't matter the order that we choose them, which is 715 different possibilities. Part B. Part B, there must be 2 of each sex. So that means we have to have 2 men and 2 women. Now remember, and means we're going to have to multiply our possibilities. So for 2 men, the ways we could have 2 men chosen is 7 choose 2. From the 7 men, we need to choose 2 of them. For the 2 women, we have 6 women, and we need to choose 2 of them from the 6 women. And means multiply. So here we have 7 choose 2 times 6 choose 2, which gives us an answer of, well, just so you know what the answers to each of those small bits is, it's 21 times 15, which is 315. Now on to part C. Now, part C is the one that I said is a little bit more like an exam question. There's 2 different ways we can approach this, and I'm going to show you both. The first approach would be to sort of go along this route above, but there's more options. We could have 1 male and 3 women, or we could have 2 men and 2 women, or we could have 3 men and 1 woman. Working out each of these, this is going to be 7 choose 1 times 6 choose 3, by the same reasoning as this one was here. 7 men choose 1 of them, and 6 women choose 3 of them, which gives us 140. This one we worked out in part B is 315. And this one is going to be 7 choose 3 times 6 choose 1, which is equal to 210. Now, because this is an or for each of these 3 things, that means the total number of ways we could do this is 140 plus 315 plus 210, which is 665 possibilities. That, I suppose, is the more direct way, but not actually the quickest way. So the quickest way to work this one out is using a different method, and that is to work out all the ways that this could not happen. So if we work out all the ways this could not happen, the only way that this doesn't happen is if we have 4 women, which is going to be 6 choose 4, and 0 men, which is going to be 7 choose 0, which is just 1. There's 15 ways that could happen. And the other way would be if there were 4 men, which would be 7 choose 4, and again, technically times by no women, which is 6 choose 0, but that's just 1. And 7 choose 4 is 35. That means there are 15 plus 35, which is 50 ways it can't happen. Now, the thing here is we know that there are 715 ways in total with no restrictions. Now, if there are 715 ways in total, and there are 50 of those which do not satisfy this, then the answer is going to be 715 minus those 50 ways, which gives us 665, the same answer as we got before. Now, as I said, this part C is a little bit more like what you're going to get in an exam question because it's a little bit more involved. It's not just a straightforward one-step process or even a two-step process. It's got a little bit more thought involved in solving it. Now, it might be that it's a part B or C like it is here, or it might just be that's straight to the question. You have to do these extra bits of working within that for a 7-mark question. So the exam questions sometimes will break it up for you, sometimes they won't, but you will probably have to go through some process similar to this one for part C.